You should have stopped and watched Burger Example 2, and this video will just help to explain that. We're going to start talking about step functions. So let's look at the first example. You should have already looked at this with Teacher Burger. A step function is a piecewise function that's constant for each of the intervals. There's no slants, there's no curves, there's no arches. There's just a constant amount. There's a constant price if you are between 0 and 13 years of age. Or there's a constant price if you are purchasing between these two levels of pounds. Looking at these intervals, it's red if f of x is, or if x is between 0 and 13, then f of x is equal to 5. If x is between 13 and 55, then f of x is 9. If x is greater than or equal to 55, then f of x equals 6.5. So in this next part of the lesson, you're taking input values, or x values, and comparing it to each of those ranges in order to find a predetermined output value, or a predetermined y value. It's an easy way to solve. If the input is within a range, the output is going to be the same. This is kind of a little summary of what you're doing. To evaluate any piecewise function for a specific input or x value, find the interval of the domain that contains that input or that value, and then use the rule that's given for that interval that the x value falls into. Here's an example. This is not the check it out for your notes page. But let's look at this together. H of x is 2x plus 1 if x is less than or equal to 2, and x squared minus 4 if x is greater than 2. You might need to pause this and just take a closer look. Let's look at evaluating for x is equal to -1. -1 is less than 2, so you would use the top function, 2x plus 1. And they show you that here, where you plug the -1 in place of the x and solve for h of x, or solve for y. And you get -1. Then you would look at the second one, x equals 4. Since 4 is greater than 2, you would use x squared minus 4. Plug in the 4 in place of the x. X squared is 16 minus 4 is 12. Make sure you pause if you need to. Make sure you understand how to do this. You first find the interval that matches the x value, -1 or 4 being the x value. -1 goes into the top, plug it into the function 2x plus 1 and solve. Plug the 4 into the second function, x squared minus 4, and solve. Be careful to watch your order of operations. Here's another example. Look at kind of a solution area, g of -1. Which function would you use if the x value were -1? -1 is equal to -1, so you would use the top, 2 to the power of x. Plug the -1 into the x position. What is 2 to the power of -1? 1/2. What about g of 4? If 4 were the x value, it's greater than -1, so you would use the bottom function. 5 times x, or 5 times 4, is 20. Pause if you need to and make sure you're understanding how to evaluate the piecewise function. Now we're to the check it out 2a. which you should be writing down on your notes page. Pause the video and do this on your own using x values -1 and 3. Plug them in for x, figure out which interval is relevant for each x value, and then find f of x. And we're on to example 2b. Here again, look at your book. The answer is on your screen, but you're responsible to make sure you know how to do it. Do it on your own without peeking, and then make sure that you're doing it correctly. If you're not, figure out where you're going wrong. This one should be written on your notes page as well so that you can refer back to it later when you're doing your homework to make sure you know how to do it and that you're doing it properly. So pause the video and check it out. Wow, I sure do get tired of doing these little videos. Alright, graphing a piecewise function. This is a little different than the step one because now you're going to have slanted lines. Now, I hope you remember how to graph slanted lines. It's your y equals mx plus b slope-intercept form. Remember your intercept or your b, you graph that first, and then you use your slope to go up and over. This example, example 3a, has two intervals. So technically what you would do is you would graph both lines completely. In order to graph the first one, you would go up to 3, your intercept, then your slope is 1 over 4. So you would go up 1 and to the right 4 and graph that line. But since there is a restriction on the line, you're only going to show the part of the line that is less than 0. Pause a minute and look at the graph so that that makes sense. The second line, negative 2x plus 3, you would go up to 3, and the slope is negative 2. So you would go down 2, over to the right 1, and connect those 2 points in order to draw your line. Here again, there's a restriction. You're only going to show the part of the line that is greater than or equal to 0. So you would color in the dot on the 0 and draw your ray going to the right greater than or equal to 0. This example is a little bit tougher. Mr. Berger showed you one like this. Dr. Berger, Teacher Berger, whatever. Anyway, you have to graph each line. So x squared minus 3, if you need help graphing that, it's okay to graph it on your calculator first and then notice exactly where that graph falls on the graph. And you have to draw it on your graph exactly the way it would fall. However, you have to watch the restriction. So x squared minus 3 is going to have a parabola shape, but you can only use the part of the graph that's less than 0. The same thing is true with the second function, 1/2 x minus 3. Now this one is a straight line. Y equals mx plus b. The intercept is at negative 3. The slope is up 1 over 2. So you would draw that straight line with a ruler, but keep in mind the only part of it that is showing is between 0 and 4. And remember that you put an open circle at 4 and a closed circle at 0. Then you're going to finish up with the other parabola. Like I said, it's probably going to be easier to graph it on your calculator, but you have to make sure that you draw it on your graph paper exactly in the same position as it is on your graphing calculator. Remember, only show the part of the graph that's greater than or equal to 4 with a closed circle at 4. Here's a picture. Make sure you're doing it right.